at this point we have, we moved backwards from where we got stuck before, right? Trying to use this automated surface paneling system on the backside. We can't do that with an automated system. So we need to repanelize the front surface of the space frame and then repanelize the back, but they happen in two different ways. Okay, so the information that we have on the front, and let me just grab a preview real quick. The information that we have on the front follows a grouped patterning where we can just create new panels, right? So these orange ones, oh, you can't really see it very well. There we go. You can see this one pretty well. These green ones. So this panel over here, we've got 0.0, 0.1, 0.2, and 0.3. So if you think back to our saddle patterning exercise, we can isolate each of those points and reconstruct a new 4-point surface for that panel, right? And it will have a straight edge that connects each of those 4 points. However, when we switch that input to these centroids that have been moved, this is what we get. 0, 0, 0, 0, 0. Because it was essential that we did not flatten that list. Okay? So now, yeah, well, we need it to stay like this. So without flattening the list, or actually I should just say with flattening the list, when I flatten it, not only does it ruin the data in the way that it's being read across the entire surface, but it gives us this problem. We have 0.0, 0.1, 0.2, but then it goes back to 0.5 and 0.6. So for every single panel, we would have to do a list item 4 times and then plug in, list item 0, list item 1, list item 5, list item 6. Well, that's not really all that good. So at this point, knowing that we've got this data processing issue, we need to find clever ways to reconstruct it and give us new panels on the backside. And it's a different behavior. But let's start with the easier one for now. Okay? So I'm going to hide this. And we're going to start moving on with a new method of panelizing the front. Okay? So what we're doing, and let me just hide this so you know precisely what's going on. I don't want to see any of the original surfaces. So really, this is what you're going to have. You have your frame in the back.
That's just a line, right?
Yeah. So right now, these lines that we have, and it's okay if you don't have them. If you didn't quite finish this particular portion, it's really a visualization exercise so that we can understand what's happening, all right? So we need to reconnect panels to each of the 4 points of these space frame offsets. Okay, so let's get started with that. The information we need, when I pulled my preview, it actually came off of the vertices, right? The groups of 4. So essentially what we need to do is grab each of those items, item 0, item 1, item 2, item 3, and we need to just draw a line or create a, well, we don't have to draw a line, sorry, I misspoke. We're just going to create a surface off of those 4 points, and then we're going to deconstruct it and grab the edges. Because that's all we want right here, right? Because we're going to make pipes. So that looks like this. If you recall, you go into Math, Domain. No, sorry, Sets, List, List Item. I'll put it above here because I'm going to start plugging a few of them in. And remember, if we're doing a list item for 4 numbers, we go from 0 to 3. I plug that into the I input. And I want to take a quick sidebar here with you and discuss kind of like your order of operations for doing things. So I know that I need to grab a list item for all 4 of these. And let me quickly drop in how we're going to do this. We're going to use a 4-point surface. And it's going to ask you to, this is under surface freeform. So the sidebar is, when we're using a 4-point surface and we're individually selecting 4 separate points, think ahead to how you're going to input the information and try to economize how many clicks you're making sometimes. Because if I want to copy this down 4 times, right? I know I need to put 4 of them in. I can do control copy and paste 4 of them and separate them like this and clean it up a little bit and then start plugging in my vertices to each one. Or the smarter decision would be get 1 string fully complete. So plug your vertices into the list, then copy them down, copy them down and space them out, and then start plugging them in. Okay? So it's just a process thing. And when we get into the latter part with all those strings that you saw that I'm going to give to you, it was very, very important. It saved a lot of time to be able to do that. Okay? So then you go through and you set up each of the points that you're going to grab. So I slid 1 to 0, 1 to 1, and 1 to 2, and then 1 will go to 3. And there we have our panels, our surfaces. So now our warped surface is being subdivided into straight edges, rather than the really awkward curves that sometimes actually go outside of the frame that we want. Does that make sense? Are there any questions? And remember, those should not be flattened. Yes?
For the index, what if you put a number slider on there? You put a number slider?
That's a number slider.
Oh, it is, okay.
Yeah. All right, so I'm going to pause here before I move on to make sure you're all caught up to that. So understanding, at this point, understanding the limitations and the opportunities of how we're working with data is incredibly important for everything that we're going to do going forward. Okay, so that's why this one is so important, and it's getting a lot of time because, you know, this is a prime example of where the manipulation of the data didn't quite work out, you know. So at first, when we were bringing this forward, we had the wrong type of data, right? The surface that we were getting behind our form wasn't right. So we have our simple panels in the front, and they work out just fine. But when we got to the panels that we were trying to create across the top, right, we tried to use another remap surface or anything like that, or surface from points, or even patch. And what happens is, even with patch, if it'll allow us, no, that isn't it. Oh, it's because it's coming out in groups. There we go. So even with patch, it's not going to give us a panelized surface from one point to the next because of the order of the points that I just showed you. So the solution here is to actually go a different route, right? So this helped us visualize, and that's why I'm asking you guys not to worry about finishing modeling this because this whole section is not going to be used to finish the model. Okay? So what we're going to do is jump back to the deconstruct brep, and we're going to jump back to the original surface. Oh, my mouse just died. And we're going to offset the surface, right? So rather than in our space frame where we took the grid of points at the bottom and we did a -1 to give us the right subdivisions, in this case we're going to offset the surface, do the same number of subdivisions, grab the centroid again and use that centroid. And that looks like this. So from surface we go to, is it under freeform or transform? Surface utility. Yeah, it's under surface utility, and you drop in offset. So the surface that we want to offset is our original surface. So this gets plugged into the S value. And you can see what it's trying to do. It gives us another surface with a distance that's rather small. And we can modify that distance by changing the numerical value of how deep it's going to be. So for us, where was our depth? Right, we used an amplitude here of a certain value. So I could borrow that. But I think what I'm going to do actually is just hide these and start fresh. Okay? So 0 less than 10. Plug that into D. And I notice right off the bat that it's actually offsetting in, which could be okay, but for me I want to offset out. So I want to make that a negative, or you could just make the slider negative. I typically like to try and work in positives and then use negatives where necessary. So I'm just going to drop in a negative here. See how it moved it to the outside? Oh, yes, sorry. That is under math operators. All right, so I've got this surface that I then need to modify. Sorry guys, my mouse just died over here, so. All right. And the really simple way of doing this is to just copy and paste this whole string over here. So if you have your U and V count, you can just borrow those. So I just copy and pasted the divide domain, the subdivide surface, and the deconstruct brep. And what that's going to do for me after I plug it into the I and the S value, so I go surface goes into the I, surface goes into the S, and I turn on this deconstruct at the end, and it gives me the same subdivisions on the new surface that I just created.
Wait, so the surface goes to the I and the S from divide and subsurface?
Yes. So let me clean this up. I'm going to make a copy of that U and V count, and I'm going to put it down here under U and V. So this is what we're looking at. Original surface gets offset by a distance that we specify. Then I copied the same set of subdivision parameters all the way up to the deconstruct phase. Questions?
Yeah, just
Okay. So we've deconstructed. We then need to grab the centroid, and it gets really simple here, right? We're kind of doing the same stuff all again. We grab the centroid of each of the faces, and see how cleanly they correspond with the geometry on the inside face. It may or may not be exactly the offset of the surface normal, but I think it could be. I'm not 100% sure. I think it could be. But I'm not going to, disclaimer is that I'm not 100% sure.
What did you get that one?
Area is under surface analysis. So here's what we have. We have our inside surfaces, and I'm just going to stretch that out to the end. We have, well, let me do this. So we have our inside surfaces, which then we want to map to each of the points some lines, right, to get our pipe. So it gets kind of simple here. We've got the centroid, and then if I deconstruct BREP on this surface, I have all of my packets of points. So that would be, this is under surface analysis as well. So similarly, I have just like this line here, so I can even copy and paste that out. Hide that one in there a little bit. So we're going to override that line with this packet of vertices and this packet or set of groups of centroids. And when I turn that on, you'll see the same geometry inside. Making sense? So I'm going to hide some of the old geometry back here. I'll leave that one on. All right, so this looks familiar, right? So we've got two methods of trying to get to the same result. And the trouble that we were having is now mitigated because, well, not totally mitigated, but what we have to do is borrow some of the information down here where we offset the surface, and now we have brand new panels to work with. Yeah, this. So I'm going to pause the video here before we move on, and the next step, I'm going to give you all those data strings that I showed you earlier, and then we're going to start plugging it in, and it's going to give us our back frame. Okay. So let me get this set up for you guys to copy, and then we'll be good to go.